Alright, in this problem we've been asked to combine our resistors. So we have resistors here, our capacitors, and our inductors, and make this a simpler circuit. Hopefully you can see that everything is in series. So we're going to be using our series equations off of this sheet to do that. So resistors in series, inductors in series, and capacitors in series. So we're using those three equations. Now, if we'll start with the resistors, so I have a resistor here and a resistor here. Now they're not next to each other, and this may bother some people. So if it does, normally you don't have to redraw this, but to help you kind of see it, we can redraw this circuit to look like the following. So our random voltage source, Vs. So we're going to have our 1/2 ohm, and then we're going to move our 1/8 ohm up here. Now why can we do that? The circuit's going to look different. Over here, let's keep our 1/16. So make sure that you make these a little more rounded for your inductors, and these are more of a triangle-y shape. So this would be our 1/6 Henry, and then a 1/10 Henry will move up here. This makes it easier to see, but you don't have to do this. And then this is our 1/12 of a farad, and then we'll move our 1/4 farad over here. So these circuits are functionally equivalent. They look different, but they're the exact same thing. Say we had some current I1. I1 goes to the 1/2 ohm. I1 also goes to the 1/8 ohm. In this version of the circuit, it's still I1 going through here. It's still I1 going through here. They'll produce the same voltage. It doesn't matter that I move them somewhere else in the circuit, at least not for our analysis. So this is these work exactly the same. This is just easier to see. Oh, we can combine these two resistors. So our equivalent will be 1/2 plus 1/8, and then when we add those, so you get a common denominator of 8, and then to make this into an 8, you got to put a 4 on top. So you get 5/8. Now this is not adding a reciprocals. This is 5/8. It's not 8/5. All right, and then we'll go to the next thing, which is inductors. Inductors add really similar to as resistors, so we're going to be adding just that way. LE, so we're going to get our 1/6 of a Henry plus our 1/10 of a Henry. Our common denominator here looks to be, I'm just going to go with 30, so we'll put a 5 on top for this one and a 3 on top for this. So yes, 3 on top for this one, and we will get 8/30, and it looks like we could have gone with a slightly smaller number, so we're going to be able to reduce this down to 4/15 of a Henry. All right, and that leaves us with capacitors. So capacitors in series, they're going to add using the reciprocals. So we got to go 1/C equivalent, and then so we could do 1/1/12 and 1/1/4, or what you can do is you just flip these. So we get 12/1. That is 1/112. And then 1/1/4 is 4/1. You just flip the fractions for all of them. And then you're going to get 12 plus 4, which is 16. And you're going to be really tempted to say I'm done, but this is a reciprocal. We need to flip this. So CE, so this will be 1/16 of a farad. And then you could redraw this circuit with just those three components to finish this up.